All right, guys, how's everybody doing? Welcome back to another exciting day in mathematics. All right, hoping everything's all right. Well, let's get started. Warm up number 119. It's very similar to the one I gave you the other day. 118 is very similar. So this is just practice. So number one reads, rewrite each expression. Part A is 2 to the negative 5th power. Part B is 1/3 to the negative 2 power. Part C is 2 square root of 2. Number 2 reads, if x to the 3rd times x to the 5th is the same as x to the 3 plus 5, which is x to the 8th, then rewrite 5 to the power of x minus 2. Number 3 reads, use the binomial theorem to expand parentheses x plus 2 close parentheses to the 3rd power. And number 4, given the sequence, write the explicit rule. Use the rule to identify the number of terms in the sequence. Sequence given is 1, 3, 9, 27, ... 243. All right, you want to pause the video so you can copy that and then work on that on your own. Just go to your notes so you can see the examples. But I'm going to go ahead and continue. All right. So our home plate for tonight is pages 754 and 755, all only. All only 754 and 755. And your nearpod code to turn in your notes and your work is in your home plate, FOZXG. And once again, remember when you log in, start with the number that of period that you're in with me and then your name. All right. So our objective for today, I can define and evaluate logarithmic functions. I can define and evaluate logarithmic functions. And once again, if you were to share with someone that's watching with you, you would tell them what is the main idea or the big concept. Yeah, logarithmic functions. And what are we doing? Defining and evaluating. All right, so in Nearpod, you're going to leave this, it's blank. Make sure you lock your toolbar and fill that in without looking at your notes. Hopefully by now you already know what they are. All right, I'll move on. But we covered logarithmic functions, starting with the term logarithm. And we said that it looked very specific, and then I gave you this, x equals to the log b of a. And we said that the x was the exponent, b was the base, and a was a given number. Now remember, I gave you a table, and then I gave you a log, which is that one, and we wrote it to its inverse, which is an exponential function. B, which is the base, x is the exponent, which is equal to the given number. And we did some practice ones, this one and this one, right? And then from there, we got into some more practice. I said, let's rewrite the log as an exponential. So I gave you this one, example 1, 1q. Example 1 super q. Example 2 was rewrite the exponential as a log. And we rewrote that, this, and that. And then we got to solving for a log. So it was solved for x. So then we needed to rewrite this. Remember that? So base 2 to the x exponent equals to, what was the given number? 1/8. And then we needed to go through the process, which is having both sides the same base, and then from there solving for the exponent. And we did example 3q. And from there we did to 3 super q. And that got us ready for example 4. Example 4 was evaluating logarithmic functions. And we were given the function f of x equals log 7x for f of 49, f of 1 over 43, and f of 7 square root of 7. And then we went ahead and did that, and that was basically your home plate. All right, well, where's that getting us ready for? So today I'm going to do an intro into the next part, which is graphing. Copy this, example 5. It reads graph f of inverse of x equals log 3 of x. And then the table, I just have x and f, oh, this should be f inverse of x. F inverse of x. All right? Let me change that. Hold on. Okay, there it is. I fixed it. F inverse of F. All right, but before we get to graphing this one, let's get started with the inverse of this one. What was the original, or where does this log come from? From an exponential, right? What is the base? 3. What is the exponent? X. So our original should read like this. F of x equals 3 to the x power. So let's graph this one. Copy this table, x and f of x. You can pause the video so you can have more time. All right, let me get started. So I'm going to do the original one in blue. So I'm going to start with the value of 0. So if we substitute that here for x, that means it's 3 to the 0 power. What is 3 to the 0 power? Any number to the 0 power is 1. Next value, 1. What is 3 to the first power? Any number to the first power is that same number, so therefore this is 3. Next value, 2. What is 3 to the second power? 9. All right, let me graph that. 0, 1, 1, 3, and 2, 9. There it is. All right, so what did we say? That the log was the inverse of this one. So I'm going to do this one with red. So if you want to pause it so you can finish graphing, that's fine. So let's start with 0. So what do we do? Oh yeah, I remember, Mr. Q. F of 0 equals log 3 of 0. Okay, then we change this to a y equals log 3 of 0. And then we change it to an exponential, so this becomes 3 to the y power equals to 0. So we have a little dilemma here. 3 to the what power gives us 0? We don't know. So instead of 0, I'm going to use another number close to 1. I'm going to use one that's a multiple of 3. So that means a decimal that's a multiple of 3. So I'm going to choose 0.3. 0.3. So here I'm going to write 0.3, 0.3, 0.3, 0.3. Okay. Some of you are like, why, Mr. Q? Well, because if 0, we couldn't find anything that 3 to the y power was equal to 0. And before I go to 1, because watch, if I put 1, we'll do 1 right after, but a number close between 0 and 1 that's a multiple of 3 could be what, 0.3 or what, 0.6 or what else, 0.9. Yeah. So for right now, I'm going to leave it as 0.3. Okay. So when you get to these, that this is a decimal, I want you at that point to change that into a fraction. And you'll see why right now when we do that the next part. So this is 3 to the y equals 1/3. You agree? Yeah. And what do we say? That we need to have the same base, but this one's in the denominator, so we're going to send it up here. So that means this becomes 3 to the -1, and all that equals to 3 to the y. So what do we get? Y equals to what? Y equals -1, and that goes right here, -1. All right, let's go with the next number. What's the next number? 1. All right, so 1. So we do the whole thing again. F inverse of x, but instead of x is 1, equals to log 3 to the 1. So this becomes y equals log 3 to the 1. We need to change this to exponential, so this is 3 to the y equals 1. You're saying, once again, this one's kind of weird, but think it through. They need to be the same base. So question, 3 to the what power gives me 1? What did we say over here? 3 to the what? To the 0. That is correct. So I'm going to write this as 3 to the 0. And that is equal to what? 3 to the y. And at this point, we can actually write our equation here. So y equals 0. So that goes right here. All right. So heads up for tonight, when you do the home plate, notice here, this is a multiple of 3 because that was the base. And whenever you're given values, they're going to give you values that are multiple of the base most of the time. So here's this one. This one was not, but we know that the 1 as an exponent gives us the same number that, or it gives us whatchamacallit, 3 to the 0 gave us the number 1. So before we go to the next number, I'm not going to use 2. What would be the next value if we're thinking about multiples of 3? Yeah, I'm going to go with 3. So I'm going to do 3. All right, so then I write what? F of inverse of 3 equals log 3 of 3. So this becomes y equals log 3 of 3. So this is 3 to the y equals 3. All right. What's the invisible exponent here? 1. All right, so there we can solve there. It's already set. So what do we have? Y equals 1. That goes right there. All right. Now, if I was to choose one more value, you know what? We'll get to that in a minute. So let's graph those for right now. We got 1/3 and -1. 1/3 and -1. Okay. 1, 0. 3, 1. Now, according to what we said in the definition, we said that these two are inverses. That means if I was to graph a dotted line in y equals x like this, they should reflect one another. So let's see. Is this one reflecting here? Yes. Is this one reflecting here? Yes. Which one's the only one that we need to reflect now? This one, right? So question. Look at this point and this point. Let me give you the coordinates of this one. This is 1, 0. Coordinates of this one is 3, 1. Let's look at the inverse. This is, let me change colors, 0, 1. And this is 1, 3. Look at these. So what would be the reflection? Let's see, this one, the coordinate is 2, 9. What would be its reflection according to the inverse? Yeah, you got it. Notice this one, these are just turned around the values. So that means the next value would be here would be what? 9, 2. 9, 2. And you can do the work, but for me, for tonight, if you do 3 points and then from there you do the inverse, and you already know the point for the inverse, you don't have to show me the work, just show me the inverse that you got it because of the coordinate was given. So let's graph this. There it is. Is it reflecting? Pretty much. The only point that I'm missing here would be one right here. So what was this point? This point was 1 third, negative 1. So what would you think it would be on the other one? Yeah, negative 1, 1/3. Negative 1 and 1/3. There it is. All right, guys. Well, this is a good intro for the graphing portion, and I just wanted you to see side by side the inverses. So for home play, they're going to give you to graph a log. They're not going to give you to graph the inverse. But I want you to graph the log, and then I want you to graph its inverse, because it's only one graph. And then from there, they're going to ask you about domain in regards to domain and range, and so on and so forth, and see how you do with answering those questions with some of the skills that you got. All right, guys. So our objective was I can define and evaluate logarithmic functions. Have we been doing that? Yes. And today we intro to graphing portion. And once again, your home play for tonight is 754 and 755 only, and your near pot code is FOZXG. And like I said all the time, if you are not moving forward, then you're already behind. So in regards to that, and just to elaborate in regards to grading. Now, some of you have been turning in work. I'm going to start going through all that work. For those of you that have been turning in your work, that counts as class participation. And yes, it's counting towards 15% of your grade. Now, the home play that you do is 10%. So the total percentage is 1/4 of your grade. So make sure you start keeping up with your work, guys. Once again, your Cornell notes and everything that we do in the lesson, from the warm-up to the notes that you need to turn in on Nearpod, make sure you turn those in, because that's counting as 15%. The home play is 10%, so it's a total of 25%. And from this point forward, all that's going to bring, hopefully, your grade up as we finish off the year. All right? And for those of you that haven't been able to log on to Nearpod to submit your stuff, remember, take pictures and email me, okay? And I've been getting some emails, and some of you just send me answers. I don't want to just answers, guys. Show me the work. I want to see what you're doing. Show the work and give me the answers, and we'll go from there. And also, some of you need to send me pictures of your Cornell notes from the videos. All right? All right, guys. Well, have a good one. And this will be the last one for the week, so I'll see you guys till Tuesday. All right? Bam. Bye.